Hey there, how's it going everybody? In this video, we're going to set up an IPSec VPN between a Juniper SRX and a Cisco IOS. Our Phase 1 tunnel will be IKE version 2 with pre-shared key authentication, and our Phase 2 tunnel will be route-based with tunnel interfaces. We're going to be looking at the iOS configuration and how it differs from the SRX, plus looking at how the iOS's dynamic peer configuration is much different than the SRX's. We're not going to review fundamentals, such as the IKE authentication process or how IKE and IPSec interoperate, so if you'd like to review that, please check out the previous videos on my channel. Here's the topology we'll be using for the SRX to iOS VPN. Over here on the left, we have SRX 0, and we're going to be using 10.0.0.0 as the loopback. Its internet interface is going to be gig 000, and its global IP will end in 138.98. The tunnel interface will be secure tunnel 0.1, and the tunnel IP address will be 1.0/31. Over here on the right, we have iOS 1, and its loopback IP will be 10.0.0.1. Its internet interface will be gig 00, and its global IP will be 102.30. Now the tunnel IP will be 1.1/31, and its tunnel interface will be tunnel 1. So using this basic topology, let's begin. So here we are on SRX 0, and we're going to spend all our time configuring iOS 1. So here on SRX 0, we're just going to verify that things are configured correctly. We're going to look at IKE, IPSec, the routing, the security zones, but all the configurations we're going to do is going to be on iOS 1. So if you're interested in learning how to configure an IPSec VPN on an SRX, either pre-shared key or certificate authentication, I recommend you check out the previous videos on my channel where I cover that. So we're going to take a look and make sure that this device is in flow mode, because an SRX has to be in flow mode in order to do a VPN, and it is, and that's the default state, by the way. Now we're going to look at our interfaces, see what we're dealing with. So we have an internet interface here, gig 000. We have a loopback 0, and we have the interface going to iOS 1, our secure tunnel 0.1. So let's take a look at our routes. So for our routes, we have our loopback interface here with our loopback IP of 10.0.0.0. We have our internet interface here with internet IP of 138.98 on interface gig 000, and we have our default route static, which is next hopping to our ISP and exiting our internet interface. We also have our secure tunnel interface here with the secure tunnel IP address 1.0/31, and so that looks all good. Now this right here, this OSPF entry, that just means we're running OSPF on the interface. It doesn't mean we have an OSPF neighbor. So you can see here, no OSPF neighbors. So let's go ahead and try to ping our peer and make sure that our peer is available and reachable. So that's 208.105.102.30 is iOS 1's internet IP. And we can ping it. So let's move right along here and check out the security zones. Make sure that our interfaces are properly set up. So we have our internet security zone with our internet interface, and it's allowing ping and IKE to the routing engine, and this IKE is also going to allow IPSec. That's perfect. That's exactly what we want. And then we have our corporate zone, which is kind of like our trusted zone, and we're going to allow all services and all protocols. So that means ping and OSPF will work in this zone. And we can see here we have interface loopback 0 and secure tunnel 0.1. So we want these both in the same zone because it's going to be our trusted zone. We're going to do our OSPF and our pings. But in order to pass traffic between two interfaces, even if they're in the same zone, we need a policy. So let's take a look at our policy. And here we have our intra-corporate zone policy from zone corporate to zone corporate. Policy is called permit any, and it says source any, destination any, application, meaning protocol any, then permit. So when we originate a ping from loopback 0 out the tunnel to iOS 1, it will be permitted without an issue. So let's check out IKE. Let's see if the IKE is set up for the VPN. Alright, so here we have our IKE proposal called IKE prop. We're doing pre-shared key for authentication, DB group 14, SHA-256 for the hash, the integrity, AES-256 for the encryption, and 24 hours for the lifetime. And then our IKE policy, called IKE policy, references the proposal and has our pre-shared key configured. So let's take a look at this pre-shared key. We're going to need it when we configure the Cisco iOS device. So request system decrypt password. So the password is, this is an SRX to iOS lab. So we're going to need that password on the iOS device. So we'll have to remember that. Then we have our gateway, and it's called iOS 1 because that's where it's going. And it references the policy that we have created. It has the peer IP address. So this means this is a static point-to-point IPSec VPN because we're calling out the peer. So it's not dynamic, it's static. We're going to be able to initiate the VPN to this peer. You can see we're using custom IKE identities, not the defaults, which are the IP addresses. So we're going to have SRX 0 as our own IKE identity and iOS 1 as the remote IKE identity. This is going to anchor on our internet interface, and we're going to be running version 2. So that looks great. So let's take a look at the IPSec portion. So for IPSec, we have our proposal, IKE prop, encapsulated security payload. We're going to be SHA-256 again for integrity, AES-256 for encryption, and lifetime of 8 hours. So that looks good. Then our IPSec policy is going to have perfect quoting secrecy turned on for group 14, and is going to reference the proposals. And then finally, we have our IPSec VPN called iOS 1, and it references the IPSec policy. It references the IKE gateway called iOS 1. It has DF-bit copy turned on, and it's bound to our Secure Tunnel 0.1 interface. So speaking of that interface, let's take a look at that and make sure it's configured. So we have here Secure Tunnel 0.1, description iOS 1, MTU 1400, and here's the address of 1.0/31. So everything looks great. Let's take a look at the final thing, which is going to be our OSPF, and see if it's configured. And it is for area 0. Loopback 0 is going to be passive, suppressing the hellos, and Secure Tunnel 0.1 is going to be running in area 0 as well. And it's going to go into point-to-point mode because tunnel interfaces default into OSPF point-to-point mode. So this is great. This looks really good. So we should see no tunnels up right now as far as IKE or IPSec tunnels. So if I look, you can see it's trying, but it's down. We have these cookies here, which simply refer to that we are sending but not receiving. So we have our one outbound init packet, but no response. And that's what's expected. And it even says here under my inactive tunnels, no response from peer, negotiation failed. So it's trying, but the other side's not responding. And this is exactly what we'd expect since the other side's not configured. So let's leave this alone and let's jump over to iOS 1 and jump into the configuration over there. All right, here we are on the iOS device. And you can see here on the right-hand side, I have a little configuration guide that's going to help walk us through the different configuration elements we're going to need to set up IKE, IPSec, and the route-based portion. But before we get to that, let's get our bearings. So taking a look at our interface descriptions, we have our internet interface, gig 00, and we have our loopback interface, loopback 0. Let's take a look at our routing table. So we have our loopback interface right here, loopback 0, with an IP of 10.0.0.1. We have our internet interface here with an IP of 102.30, and the network on that interface is a 102.0/27. Then we have our static route, an all zeros route, which is next hopping to our ISP at 102.1. So I fully expect we'd be able to ping SRX 0, since SRX 0 could ping iOS 1 when we tested before. So let's take a look, and yep, we can ping no problem. So it looks like we're set up here to begin our configuration of IKE, then IPSec, and then finally the route-based pieces. So let's get started. So in configuration mode, we're going to go into, start right off the top here with IKE v2 proposal, and we'll call it IKE prop. So we have a warning here which says, if you're going to use an algorithm other than GCM, you need integrity and Diffie-Hellman. But if you're going to use GCM, then you need PRF and Diffie-Hellman. We're not using GCM, so we're not going to configure the PRF. We're going to be using just good old-fashioned AES-256. So if we go here, we're going to pick encryption, and we're going to say AES-256. This is what we're running on SRX 0. And then for integrity, or the hash, we're going to use SHA-256. And then finally, for the group, which is the Diffie-Hellman group, we're going to use 14. And that's it. That's all we have to configure. So if I do a do show crypto IKE v2, proposal, you can see that there's a default proposal. That's a thing that Cisco kind of likes to have, is default settings and default setups to make things easier. But we don't want to use the default, so we configured our own, which is called IKE prop. And we're using encryption AS256, integrity of SHA-256. We didn't have to configure the PRF, the pseudo-random function. It automatically matches whatever you have configured for integrity, and that's how it works on the SRX as well. The SRX, you do not configure the PRF. It just matches whatever you have for integrity. And then Diffie Hellman is going to be 14. So this is great. Let's move on to the next step, which is the IKE policy. So crypto IKE v2 policy, and we'll call this IKE poly. So here it says the policy must at least have one complete proposal attached. So it's very similar to how the SRX is set up. We need to reference the proposal we just created. So IKE prop. And there's only two other settings you can really do in the policy. And it's not the pre-shared key. So like on the SRX, this is where you configure the pre-shared key, but that's not how it is on iOS. So first you can configure the address, which is what we're going to do. This basically says any IKE traffic landing on or originating from this local address will use this policy and therefore use the proposal affiliated with this policy. So we want to do this. So we're going to match it to our internet IP here, which is 208.105.102.30. So this will force it to use our custom proposal whenever we're initiating or receiving IKE traffic. The other thing here, which we're not going to configure, is this forward VRF. That's if you're doing custom VRFs and your external interface is in a non-default VRF. It's not in the global VRF, it's in a custom VRF, then you would call that out here. Or if your policy is going to serve a bunch of different VPNs on different interfaces, you can actually set it to all. But by default, it's global, and so we don't need to set it. So let's take a look at our policy here. So again, you see there's a default policy, but we're going to use our custom policy here. The FVRF is global, that's fine because we don't have any custom VRFs. Our local IP address is going to be our internet IP, and it's going to use our custom proposal. So that's perfect. So the next configuration element is going to be the profile, and we'll call it SRX 0. Now, these profiles can serve multiple peers, and that's why right here it says the profile must have match identity, match certificate, or match any. It can actually serve multiple peers with one profile, but in our case, we're going to use this profile just to serve one peer. So we're not going to say match any, we're going to say match a specific identity. So we're going to say match identity, and the only choice is remote, and it's going to be an FQDN. That's what iOS calls hostname. So we're going to say FQDN, and then we're going to put in the FQDN, which is SRX 0. The next thing we're going to do is, since we're at it, let's go ahead and configure our own identity. So you say identity local, again FQDN, and we're supposed to be iOS 1. So now the local and remote IKE identity is now configured based inside of this profile. The next thing you saw up here is that you have to define the local and remote authentication method. So this is where you define the method of your authentication. So we're going to go ahead and say authentication remote. So how we're challenging our peer. We're going to expect them to use a pre-shared key, and we'll define the key right here. And if you recall from what we saw in SRX 0, the key was this is an SRX to iOS lab. Now then we're going to go back and we have to do the local. So there's a couple things to talk about. First is you can see you can use a different method in each direction. We're not going to do that. We're going to use pre-shared key in both directions. So remote is how we're challenging our peer, and local is how we're responding to the challenge coming from our peer. So we're going to say pre-shared in both directions. The other thing you'll notice is in both cases I don't have to define the key. I can just hit enter. Again, that's in case this profile is serving multiple peers. You can then create something called a key ring in the global area of the config, and you can kind of scoot the management of your keys into that key ring. So you define your peers and what keys are associated with them. And that kind of makes it easier if you're using one profile that is serving many, many peers. Since this profile is serving one peer, we're just going to find the key right here under this profile. So this key always gets used with this profile, and it's going to be the same key. All right, next thing we're going to want to do here is we're going to want to set the lifetime. And the lifetime is going to be the max, which is that 24-hour period of 86,400 seconds. And that's the default lifetime for Cisco iOS, by the way. So that should be it. We have our local and remote IKE IDs, our local and remote authentication method and key, and we have our lifetime. So let's take a look and see what we see. So it's going to be IKE profile. So you'll see there is no default profile for IKE. So there's just the custom profile we created, SRX 0. We didn't set the forward VRF, so it's working in global, which is perfect. We're going to be matching remote identities of SRX 0. Our local identity is iOS 1. Our authentication methods are pre-share. We don't have any key rings configured. Our lifetime is 24 hours. Dead peer detection is disabled. That keep alive is disabled. And that's pretty much all we need to know off of here. So we are now done. We're done with phase 1. We're done configuring IKE. And everything looks good. So now we can jump over to IPSec. So let's configure IPSec. Crypto, IPSec. Now the first thing we need to configure is the transform set, which is what iOS calls the IPSec proposals. So we're going to say IPSec transform set. Here, let me exit out of this. So crypto IPSec transform set, and we'll name it IPSec proposal, since that's what it is. And here you can see all the different phase 2 encryption and encapsulation algorithms we can use. So we're going to use ESP AES, and it's going to be the 256-bit variant, because that's what SRX 0 is using, and we're going to use the integrity or hashing algorithm of SHA-256. So this is what we want. You'll notice here that iOS lets you use authenticated header with ESP. It's not something I would recommend, but you can do that if you want. So when you hit enter here, it actually creates the transform set and it lets you go into this little sub mode or sub area. And here's where you set the mode of the encapsulated security payload, either transport or tunnel, and we want tunnel. All right, so now our IPSec proposals are created, also known as the transform set. So now we go on to the next piece, which is the IPSec profile. And the IPSec profile is kind of like a hodgepodge of what you would see on the SRX as the IPSec policy and the IPSec VPN. So all the settings you would find split under those two are all put together under crypto IPSec profile. So we'll say crypto IPSec profile, and we'll call it SRX 0. So there's just a bunch of stuff that this is going to tie together. The first thing it's going to tie together is it's going to reference the IKE v2 profile we made, which was SRX 0. The next thing it's going to tie together is the transform set we just created, which we called IPSec proposal. And another thing we set here is the perfect forwarding secrecy, which is going to be group 14. And the other thing that's going to set here is some of the security association settings. So one of them is going to be the lifetime in seconds. So that's where we're going to set this to 8 hours or 28,800. And the default, it's only 3,600 seconds, which is 1 hour. So we are changing that from the default. And the other thing that we're going to do here is DF-bit copy. So now we've matched the settings that SRX 0 is using. So there we go. We have the profile set up. And let's take a look at both of these. So if I say do show crypto IPSec transform, you can see here's our custom transform set of IPSec prop using the settings we want in tunnel mode. And then you can see there's a default transform set if you wanted to fall back to that for some reason. And then you can also do show cry IPSec profile. And again, there's a default profile down here. But up here's our custom profile, SRX 0, which is linked to our IKE v2 profile of SRX 0. Lifetime is going to be that 8-hour period. Responder only is turned off. Perfect forwarding secrecy is turned on, running group 14. Mixed mode is what Cisco calls it when you do IPv6 encrypted inside of IPv4. So we're not doing that, so we did not turn it on. It's off by default. And then we have transform set. The custom transform set that we made is referenced right here. So everything is looking really good. We're really far along here. We're done with phase 2 now. But right about here, especially if you're familiar with SRX, you're probably thinking, gosh, we didn't really configure a peer IP or an external interface. You know, when you do an SRX device, under the IKE gateway, you configure the peer IP and external interface. So what's going on with this iOS? Because we don't have that configured anywhere. This match address local under the IKE policy is simply just to trigger when to use this proposal. It has nothing to do with the destination or source to originate the IKE session from, or to receive the IKE session on. And there's no peer IP under the profile, there's no peer IP under the transform set or the IPSec profile, no interface is referenced either. So at this point you might be a little confused, and this is kind of where things differ a little bit, because on the SRX the secure tunnel interface is pretty lean. It has the description, which is optional, it had the MTU, which is optional, and it had the IP address. But on Cisco, it's actually going to have more than that, and that's where the iOS is going to derive the local interface and the peer IP that's going to be used to bring this VPN up. So let's begin configuring the interface, which if you look under this route-based section here I have on the right-hand side of the screen, it says VTI. That's what Cisco calls their IPSec tunnel interfaces. They call it the virtual tunnel interface. So let's take a look at that. So we're going to create a tunnel called Tunnel 1. And Cisco uses these tunnel interfaces for a whole bunch of their different tunneling technologies. So if I say do show interface tunnel 1, you'll notice that this tunnel, when it's created, is automatically in GRE over IPv4 mode. And I can change that. If I go here and say tunnel mode, there's a bunch of different modes it can be in. The GRE mode, the IP and IP mode, which is like GRE, but less overhead, but also less capability. The IPSec mode, that's that virtual tunnel interface I was talking about that we want to use. There's also IPv6, which is GRE packet for IPv6. There's also IPv6 over IP, and then finally MPLS for like traffic engineering. So this interface can be used for all sorts of things on an iOS device. We want to use it for IPSec, and it's going to be IPv6 over IPv4. So the moment we do that, this now becomes a VTI interface, a virtual tunnel interface. So it says IPsec over IPv4. So now we can begin to configure the rest of these settings we're going to need on this tunnel interface. So we'll start with something simple like the description, which is SRX 0, because that's where it's going. And then we're also going to figure the IP address, which is 172.16.1.1, and the mask is going to be a /31. We'll also configure the IP MTU, which is 1400. And then here's where we get to the part that is really different. We configure the tunnel source. So this is going to be the IP address that our IKE traffic is going to originate from, and our IPsec traffic is going to originate from. And it's also the interface that we're going to expect IKE and IPsec traffic on. So we're going to configure it to an IP address, 208.105.102.30, which is our internet-facing interface. It's the global IP on our internet interface. Next, we need to configure the tunnel destination. So this is basically the configuration of the peer address. So on the SRX, you configure a peer address on the IKE gateway and an external interface under the IKE gateway. These two commands, tunnel source and tunnel destination, are the iOS equivalent of that. So I need to put SRX 0's global IP right here, which is the 138.98 IP. And then finally, if I leave it alone, this VTI is going to use the default IPsec profile that we looked at earlier. But we don't want to do that. We want to use the custom profile we created. So that's going to be tunnel protection IPsec profile SRX 0. So now it's going to use the custom profile that we created. Now before I move on from this, I do want to point out something, which is because we're defining the destination, this is a static VTI because it's a static point-to-point IPsec tunnel. So just like on the SRX, when you define the address of your peer, it's a static point-to-point IPsec tunnel. Likewise, since we define the tunnel destination, this is a static virtual tunnel interface. So now that we have that, let's go to the routing protocol. So we'll say router OSPF, and we need a process ID. It's locally significant. It doesn't matter what it is. We're going to say 1. We're going to go ahead and set the router ID, though, to our loopback IP, which is 10.0.0.1. And then we're going to put the loopback 0 in passive mode, so we don't send out hellos on our loopback interface. We don't need them there. Then we'll run the network command to get OSPF running on our loopback interface. And I'll use a wildcard mask of all zeros so that it's just that IP. So now we have OSPF running on our loopback. Now let's get it running on the tunnel interface. So that's going to be 172.16.1.1. And again, we'll use a wildcard of all zeros for an exact match. So that should be it. That's our routing protocol. That should be it. So let's take a look and see if OSPF is running on our interfaces here. So you can see for our loopback, OSPF is running, and you can see for our tunnel interface, OSPF is running, and actually it's already up. We already have a neighbor. Now, do you see this right here? So by default, if I scroll up, by default, iOS has the tunnel interfaces with a pretty low bandwidth. So it's a bandwidth of 100K, but the default reference bandwidth of OSPF is 100 megs. So that makes the cost 1,000. And Juniper SRX is not like that. Its tunnel interface is just going to be a cost of 1. So if I want to fix this real quick, just so we have a little bit of symmetry when we're looking at the route table and looking at things, I'm going to hard set the OSPF cost to 1, just so that is a 1, and that way when we're looking at our routes, it's a little bit easier to see what's going on. So I'm going to take a look at the routes, and you can see I do have one OSPF route here to the loopback of route SRX 0 across tunnel 1. So let's see if I can ping that real quick. And I'll source it from my own loopback. And I can, and it works. So that's good news. Right now you've just seen how to configure a point-to-point static VPN between a Juniper SRX and a Cisco IOS. Now let me show you the different show commands that are going to help you if something goes wrong, because there's some IKE show commands, there's some IPSec show commands, and then there's like some generic show commands that are kind of interesting. So starting with IKE, I just want to point out you have the policy, profile, proposal. These don't look at real-time information. This is how you look at what you've configured. Those are the commands we've already used before, and how I was showing you the policy and the profile. And if you remember, there was a default policy, there was a default proposal. So this right here is the real-time information, the SA, the session, and the stats. So let's start with the SA. And you can see it says our local IP is this, our remote IP is this, no VRFs in play, status ready. You can see all of the IKE proposal settings that were agreed to, and you can see the lifetime. If I add a detail onto this, it gives a little bit more beneath all that. So it says the local and remote SPI values. These correspond to the responder and initiator cookies that you see on a Juniper SRX. So same concept, and these numbers will match too between the two. And then negotiation done, local IKE ID iOS 1, remote IKE ID SRX 0, and it even says dead peer detection is not turned on. That's why it's all zeroed out. NAT is not detected. So NAT is on, but no NAT is detected. And then are we the initiator of this SA? Yes. There's another command that's very similar to this one called session. And the way it's different, it's very similar, but the way it's different is it has this extra line right here that's even more descriptive about what exactly is happening. So I really like it. If it says up active, that means you're basically passing traffic, or you should be. If it says up idle, it means something's wrong. It only means that IKE is up, but IPSec isn't. And then here it says how many SAs for IKE? 1. How many child SAs or IPSec SAs? 1. And it even has the child SA information, right? The traffic selectors and the SPIs. So if I do a detail on this one, it's again similar to the other command, but I get this extra information down here about the phase 2 SA, which I think is pretty nice, including the proposals we used and the mode we used, tunnel. So another command is the stats, which is pretty useful, but perhaps not as useful as the Juniper SRX statistics, which gives you like packet counters and byte counters. This seems to be kind of more generic of, hey, we had an outgoing IKE request, it was accepted, and now we're happy. So it doesn't really tell you packet counts or anything like that. So then also going over to IPSec, on this side of the house, policy, profile, security association, and transform set are all just to look at your configuration elements. None of those are real-time information. That's just what you've got configured in the running config. It's this SA that shows you the real-time information of the IPSec SA that's currently up. You can see it's affiliated with Tunnel 1. You can see the local IP address, the peer IP address. These are the traffic selectors, also known as the IKE proxy identities. And if you go through here, you'll see that it has the phase 2 proposal. So tunnel mode, ESP 256, SHA 256. The only thing that I believe is a bug is this right here, because I haven't seen this in the real world, but I'm seeing it here in the lab, which is, it says perfect forwarding secrecy no, Diffie-Hellman group none. We have that turned on both sides, so I believe that's just a bug. And then there's really two more commands besides all those that are kind of more summary commands. One of them is sockets, which kind of shows it more from a bird's eye view. So you have tunnel 1 peers, it shows the local and remote peer IPs, the IA proxy identities that are being used, and the profile that's connected. So that might be useful. This looks like it'd be really useful if you had lots of tunnel interfaces and lots of peers. And then the other one is show crypto session, which is I like better actually. It says a lot of the same information though. I just like the format better. So tunnel 1, profile SRX 0. Again, we get that nice up active message that I like to see. Our peer IP address, the local, the remote IP, that it's active, and the child SA. Really, this is the traffic selector, but it says that we have our SAs are both active. So, and then this is the detailed version of that command, which just gives you some counters here for IPSec. So yeah, I really like this command right here, this show crypto sessions detailed command. So right here, I want to talk about if we were to switch this to dynamic, right? You saw us do static. It's actually pretty straightforward. Let's talk about dynamic. So let's jump back to the SRX side of the house. And what I want to do is I want to enable dynamic mode on the SRX, show you what it looks like, show you what it feels like, then revert it back to static, and then we'll go back to iOS and I'll show you what it takes to get dynamic running on that side. So when we say dynamic, what we're talking about is we currently have a point-to-point IPSec VPN between SRX and iOS, and it's a static point-to-point because both sides are statically configured to talk to each other. Dynamic means one side doesn't know the other side's peer address, and so it's going to go into responder-only mode and wait to be initiated on. And the only information it's going to have is the remote IKE identity. So this would be used in a situation where one of your peers' IP address is either constantly changing or it's not practical for you to know what it is. And so like maybe it's a DHCP, so yeah, it's constantly changing, or maybe it's moving around. Maybe it's like on 4G or Wi-Fi or something. So let's get that configured here on the SRX. It's going to be done under the IKE section. So right here under IKE, we have to delete this address command because this is what makes it a static point-to-point VPN. And instead, we're going to use a command in its place called dynamic. But when you do dynamic, you have to call out the remote IKE identity so that the SRX knows which peer is supposed to land on this IKE gateway. So it's going to be hostname iOS1. Now you'll notice this hostname iOS1, we already have that called out right here in this remote identity command. Well, actually, we got to get rid of that command too, because if I try to commit it right now, it'll actually say, since the remote gateway is dynamic, define remote identity under dynamic. So, and that's what we did. So when you use the dynamic command, you're supposed to call out the remote IKE identity under that command, and you're supposed to get rid of this remote identity command, because this remote identity command is only used with a static peer. So I need to delete this command, and then it should commit just fine. I'm going to have to go back to the iOS and clear out the IKE session so that it knows it's down immediately, and we'll start to bring it back up. So if you remember with IKE v2, the IPSec and IKE are linked. So if I clear out IKE v2, it clears out IPSec as well, flushes everything out, and now Cisco will start to try to reestablish this. All right, so it's back up now. Show OSPF neighbor. You can see the OSPF neighbor's up. And let me make sure I can ping through. And I can. So this is what dynamic peer on a Juniper SRX looks like. It's pretty similar to how a static peer is. And so because of that, it's kind of simple. There's very little changes, and the changes are all under the same area of this IKE's gateway section. So what I'm going to do is I'm going to change this back from dynamic back to a static peer, because I want to show you what it's going to take to do a dynamic peer on the Cisco iOS side. So we're going to roll back that change, which is going to put it back to a static peer. And then we're going to prepare this side with another change. So the other change is going to be under my interfaces, under my secure tunnel interface. I need to change this IP address because when you, on the iOS side, when we put it into dynamic mode, it's going to require that we use a /32 IP address. And we can leave this as a /31 IP address, but it'll show us some weird output, and everything will work, but it'll show us some weird output in the routing table. And so just to make things clean, I'm going to remove this IP address and put it back as a /32. That way, OSPF knows that neither side are in the same network, and we're just dynamically learning the IPs across the point-to-point tunnel by virtue of the OSPF neighborship, and not because they're sharing a network. So those are the two changes I want to make. Let me commit that. And let me get back to the Cisco. All right, so the way we got to get this into dynamic mode is a little strange. So first of all, we don't get to keep our tunnel interface. We got to get rid of it. And in its place is going to be something called a virtual template. And this virtual template is a static, inactive, latent template that is only for configuration, not for production. And it will be linked to our IKE profile. Then, when a connection is made from, because remember, we'll be a responder only since we'll be in dynamic mode. Then when a connection is made, IKE will kick off the template, and the template will clone an interface, and that interface will be called virtual access. And that interface will be the production interface, and that interface will inherit all the settings off the template. And the only gotcha about this is that the template can't have the same IP address as the virtual access, as the clone, unless the IP address is borrowed from a loopback. So the way this works is, again, a little strange. We have to get rid of our tunnel. We have to create a new loopback, and we're going to call it DVTI, because what this was a static virtual tunnel interface, SVTI. What we're about to do is a dynamic virtual tunnel interface, or DVTI. So I'm going to call this loopback DVTI so we know what it's doing. And we're going to put the IP address right here. And it's going to be the same IP address, but it's going to switch to a /32. And that's why I switched it to a /32 on the SRX, just so it kind of matches on both sides for sanity's sake. So now that that tunnel is created, now we can create our new interface, which is called a virtual template. And you can give it any number. It's kind of like a tunnel interface. We'll give it tunnel number 1, or template number 1. And we need to define the type as tunnel. And then right here is where all these settings go that we were using on our SVTI tunnel. So description, SRX 0. The IP address is going to be something special. It's going to be IP unnumbered, which means we're borrowing an IP address from a loopback, loopback 1. Then we're going to copy the MTU, the OSPF cost, the tunnel source, and the mode is all going to get copied. And then the tunnel destination, because it's the dynamic VTI, is going to be dynamic. So that's what's going to make the difference right there. And then finally, we need to put the custom tunnel protection on, the custom profile we made. And that's it. That's all we need for the template. So let's just kind of look at our work here and see what this looks like. So here's the virtual template type tunnel we just made. The only difference between the tunnel 1 interface we had was that the IP address is now called IP unnumbered loopback 1, which means we're borrowing the IP that we put on loopback 1, which is right here. And also the tunnel destination is now dynamic. So now let's look at this interface, doing a show interface, and just kind of see what it says. So you can see it's up, but line protocol down. The line protocol will always stay down because this is not used for production. It's used as a reference. And then you'll see here it says interface is unnumbered using address of loopback 1. So that's the address we're using. And then it knows it's down. It knows the source, but it doesn't know the destination yet because we haven't done the last setting. And it knows the tunnel protection is profile SRX 0. So the last thing we need to do here is, see, when you're doing a static VTI, the tunnel interface knows the source and destination. So the tunnel interface is the vehicle that kicks off the IPSec, either by receiving or sending traffic. Well, that's not the case with DVTI because it can only receive, we can only be a responder. So we need to give the IKE profile the mechanism to reference this virtual template and kick off this virtual template and cause it to spin off a clone for us. So if we do show run begin crypto, right here under the profile, we need to add a command, and it's going to be this virtual template command. So we add this and say virtual template 1. Now, when an IKE session establishes successfully, it will know to kick off a virtual access interface from virtual template 1. So let's look at our interface descriptions. So it's already up. It's already done this. So if you look, here's virtual template 1, which will always be down. It's the reference. And then here's the virtual access interface, which is up. And this is a clone. So if we look at this interface is called virtual access, and it even says tunnel vAccess cloned from virtual template 1. And notice how it knows the source and destination. And all the settings that we put on the template are inherited on this virtual access. So if we do show IP OSPF neighbor, boom, we're neighbored across the virtual access interface. If I look at my routes, my OSPF routes are being learned across the virtual access interface. And notice that now it doesn't see the other side is in the same network because we're running /32s. So now we're learning 2 OSPF routes, the loopback, but also the /32 that represents that side of the tunnel. And just so you know, these IP addresses do not have to be in the same network. So for instance, if I were to jump over to SRX 0 and I say, okay, you know what? I don't even want to run this IP. So let me delete this IP, and I'm going to set another IP, completely different one. I'm going to set it to 31.0/32. So that's not even very close, right? So it's a much different IP address. Now, will we be able to neighbor up this way? And the answer is we will. It should cause a hiccup, but oh, there it goes. So hold on, we're resyncing. It says up, and now we're adjacent again. So we just drastically changed the IP address, no problem. We're right back up, and we should have our routes. And there they are, and we should be able to ping. So I should be able to ping Cisco loopback from my loopback. And we can. So if we jump back to Cisco, just to kind of see what that looks like, we still have our 2 OSPF routes, the loopback and the far end IP of the tunnel. And this just goes to show you how interesting this is. You can have, on point-to-point interfaces, IP addresses that don't belong to the same subnet, and they can be dynamically learned if you're running a routing protocol that peers using multicast. So whether it's EIGRP or OSPF or ISIS, this is a really cool feature. There you have it, folks. How to configure an IKE version 2 pre-shared key authenticated route-based IPSec VPN between Juniper SRX and Cisco IOS. Do me a favor and like the video if you found it helpful, and subscribe if you're interested in seeing more. Thanks for watching.